I forgot to start recording. So I was talking here, at least who was in the streaming watch. So I was just explaining this part of memory. It's uh, I don't need to go over all this alone again. But anyway, this part is uh, this today I'm starting the second episode of this series of building an Gameboy Emulator with Rust. So uh, we read yesterday. We went through this documentation from those guys on PyBoy, and I also uploaded the video in my YouTube channel. So I let the description here in Twitch, and also the Twitch link and the YouTube. So if you want to see the other episodes. So this is the second episode. We are. I'm still very early in the development of this stuff. Like I said yesterday, I started uh, getting as base the Chip 8 emulator, which Alexander did. And that was, I mean, I follow his videos, and that was like very straightforward because they don't have this kind of complexity in the ship 8, and ship 8 is more like a virtual machine than it's more like strictly it's only 33, or I don't know, it's just a few opcodes, most of them. So for drawing in the screen, it's a opcode directly to draw in the screen, and it draws using uh, so uh, bits. So just if the bits, or it's or there's just two colors, and it draws the pixel with the bits in that byte. So which is very different from what we will see here in Game Boy. For video, I was talking about this. It has this tile uh, stuff, which is a set of tile sets that are spread across the background by the PPU, or pixel processing unit, uh, and it's all handled using this part of the run, and also using this top, which is zoomed here, to perform some operations like moving the tile from the one area to another. And there is a lot of of patterns here to move the one tile, to color those tiles, and so on. So we will go over this, of course. I will go over this. I need to go over this to get to the end of this project. So uh, why I'm telling this? Because I found myself like, wow, this is so big. Why I choose this project? But uh, I was trying to create this streaming. I was trying to get one time in my entire day to dedicate to myself to learn something that I really like, and I really like this. So let's do it. Yesterday I was reading this document here in this streaming. We left it. I think we left it here. Where? I think it's in the boot room. Yeah. Yeah, because we didn't saw this. Yeah, I think we find it in the arithmetic logic unit, which is the accumulator. With Scotland, we already saw that we have this 60, no, these 8 registers, two special ones, which is the stack and program counter. This is the very basic stuff that CPU will work. But this is, I mean, after reading this yesterday, I went to this. Okay, we have those special registers, and this is not. Besides the, of course, the opcodes are the most big part of the coding that we will be doing. That I'll be doing. This, I think the hardest stuff is like a sound and LCD, because putting those strings in the screen is not so easy like it seems to be in chip 8. Uh, so, but, so I was reading this and I was looking for other stuff, so that I faced this boot ROM. What is this? This is a part of the memory that is already inside the Game Boy CPU, and it's used for, and this is why this area of ROM should not be used. Normally these have only headers for the ROM and the Nintendo logo. But this, one of the things that this boot ROM does is displaying that nice Nintendo logo. This one. It displays this. It's responsible for displaying this and the shining ting in the beginning. And this is a funny stuff because it actually, well, this part of the ROM was something that they, like we can see here, many a lot of work was required for doing that. They took a picture of the physical circuit and transformed that to bits, and then after that they disassembled that in assembly stuff. And basically what it does, it's like initialize stuff, like clear we run, copy that Nintendo logo, scroll the logo, so do that, uh, and also look up, check the logo data, because the cartridge itself needs to have the same logo inside it, and it's like there's a check if that is there. That was used for avoiding trademarks and stuff, uh, problems. Actually, if somebody develop a game that do not contains the Nintendo, it will not run, and if it contains, it is not licensed by Nintendo, it is a trademark violation. So that kind of stuff this is why they put this logo there. So this, but the interesting part of this is this ROM. This is a ROM. This is a small part of data that is a read, that should be that should be a read inside the emulator, uh, for doing this match. So what I was thinking is, because then I come up with this idea. How should I start? So we have these thousands, yeah, like, to be precise, it is 244 normal opcodes and further, so 400, 490, no, 500 opcodes, almost there. So something like 500 opcodes that we need to implement. and it could be like a so and how it is implemented. We will should be reading the file and doing the opcodes, right? So uh, I could prepare the code for be prepared for those 5,000 500 of uh, opcodes like before even loading a screen. But that will be like tedious, and I will not be seeing anything. So I choose to use the strategy that Alexander from the Chip 8 emulator did. So what he did, he creates a very basic CPU structure, and actually he started only opening the file inside the Rust. So we could do that with a normal ROM, which I have the so I have this Game Boy. So I have this Tetris. I could be using this Tetris for doing this stuff, which should be a real game. But as we need to have the boot room, which I just saw, which I just said, so this part of memory should be there, should be in the uh, code. So why not hard coding the boot ROM, which is already decoded, hard code that in the file. So actually reading this file, which is this one, which is already open here in the X editor. So I can read this and start doing decoding these opcodes. With this part of the ROM, I should see the Nintendo logo going and doing all the stuff. So I don't need to go over those 1,000 for 5,000 opcodes to be able to see something in the screen. So maybe not today, but tomorrow maybe we can able to see something, or at least debug something and see something meaningful for us to continue doing this. So what will be my idea? Uh, so and well, how I come with this idea? Actually, I borrowed this idea from this guy called Mitskela, Mitkela.com. He created this SWAT GB in JavaScript. No, not WebAssembly, in JavaScript, pure JavaScript. And he talked about that. And then he said that his idea was to creating this uh, Game Boy in one day. I think he got close of that. So, but he started doing those opcodes, which I'm not so. I don't want to do that to see something. But he said he had the same problem, which I'm having. Not which I have. It's like he said that he thought that CPU was the bulk of work, but no, this display is something that, yeah, like he was like me. Why I am aware now. I vaguely know which is this all attributes memory, which is this part of the memory, which will be used to handle the video RAM. So, uh, but he discovered that so he after some tests he was able to see. It was quite a lengthy moment to run the boot code and finally to see the Nintendo logo. This small phrase here, oh, you're not seeing this completely. So here, makes me think, okay, so I will make this thing run. At least this. I do not care about the memory banks right now. I do not care too much about all the display stuff, neither all the instructions. I will read what is in the boot ROM, try to make these opcodes, all these opcodes that I need to understand, run, which is I think I have this boot ROM, so disassembly. Okay, I think it is somewhere. So I think I got it from the wiki. Where's the wiki? Here. Hmm. Here, the bootstrap, and here so this is the content in assembly, of course, of the bootloader. So this guy disassembled it and provided in a bin file. The disassembled run can also be found here. Here. Somebody did this stuff. So what I'll be doing is going through this file and decoding this. For doing that, let's start. Let's start coding. Oh, actually, this is not the code. My code is not anywhere. So I will be doing a cargo new. Let me open this. Very nice. Oh, I'm not displaying this terminal. Nice. Okay. So then let's do cargo new. How can we name this? Of course, Game Boy Emulator. Mm. GB Rust. Okay, so Grust. GBrust Emulator. GBrust Emu. Okay. If I still remember how to start up a project, we should have a cargo here. Okay. So then we can open it. We can open it, this new project, in my so now oh yeah, let me open this. Mm. Okay, the code is pretty much legible. Okay, so here we have the okay. So if we do cargo run, we should have a hello world. So what we should be doing. So we should so oh something about my editor. I'm using this IntelliJ C Lion with the Rust. Sorry, I think my cat. Yeah. Mm, yeah. Say hello. Say hello to everybody. Let's do a Game Boy stuff. Her name is Gatuna, which means big kitty in Portuguese or something like that. Yeah, I'm not very good with names. So I'm using C Lion with the Rust plugin, which is pretty nice. I'm also using the VI emulator because I like the Vim motions and so on. Well, so that's stuff. So we need to read the boot ROM file. Okay. So let's be doing that, but I think I need to do something here. Okay, so maybe hide this. Oh, I actually don't want to do something like this. And be jumping between I'm still getting used with this OBS stuff and so on. But well, I just misclick. Okay, so let's read file Rust. Well, I should have this. And read no methods. Read. Rust file read to vector to byte actually. Yeah, I think this is what I want. Yeah, this one. Read to the end. Read all bytes until your F and the source place and then into buff. So yeah, we will be using. Yeah, so like as I said, I am also new in. Okay, so let's be doing this. So yeah, I will be doing. Okay, let's create one directory here called ROMs. And I will copy this run to there. Okay, so here it is. So we have the boot ROM here, which is a kind of ROM. File open. I think it is something like this. ROMs, or is this way? ROMs DMG ROM bin. Of course, we need to use that. This should be, I think, escape head. Okay. That creates buffer, which will be our ROM file. To be a vec new. Okay. So then, after we do this, and it will receive the buffer. Oh yeah, it should be multiple. So Let's print. Like doing some debug, I think it will be something. Well, I think I need to iterate. Yeah, of course. Print the content of back rust. Yeah. Okay. Iterate. Okay. So I think that for so this okay. So this is like it the bytes into the places. All bytes read from this function will append into a specific buffer. This function will continually score it to append more. It's a vector. Yeah, so it's a vector of bytes. Okay. So if I for byte byte in uh, mhm. Sorry, of course. Mm, I think I can do. Yeah, I can do this round wrap. And this is cannot find the path. So how it should be? Let's see. Rounds. DMG round on me. Let's see if I can finally load this file. Yeah, it reads the file. Yeah. So we, of course, this wrap here. Oh, now I saw that the little camera is on. So yeah. Oh, I'm getting here. So this unwrap here, it's not very nice. So we read the boot stuff, yeah. But of course, this is reading as a byte. So, okay, 4 byte as U60. U60. Rust casting type. No, it's not casting actually. It's like read byte as. Okay. Should read that. Hmm. Hmm. I think I put it here. I think so. Hmm. Of course, it's a byte. So if I run this, okay, so I. Mhm. What about if I do this? Oh yeah, let's do this. Of course. So I need to run to load the code. So it's write a byte. Okay. So the bus will have da, 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 da. So okay. should be okay. Oh, it's in CPU. Okay, run instruction self bus. Oh, I can use 16. I can't just. Well, guys, I'm trying to make this. Oh, I'm trying to make this code run and show me the exa decimal U8 cannot cast U8 as a yeah. So I think here is the problem is this. And I think this. Mm. Yeah. So first, I need to do this as I use 16. So I read this byte as I use 16, and need to do this debug notation to it to be printed uh, as so how can I do this without in println? Well, anyway, so I can yeah. So we are printing this 031 with which is the this, and we can start now. So we just to recap what we are doing, we are reading the boot ROM, the that ROM that's inside Game Boy by default, and we need to put that in our emulator. I'm not sure if we need to put that in our emulator, but anyways, it has valid opcodes there, which makes that Nintendo logo slide up, down, and do the shine. So if you are able to run all the opcodes that is inside this boot ROM, which is in this file, we are able to at least see that Nintendo logo. So that is what we are doing now. We just so this is the exa. It's a normal exa editor here. So this is the contents of this ROM file. So the contents of this file is this 31 FE and so on, which is our opcodes that we're gonna do next. But the first challenge was, and that is more like Rust challenge than Game Boy challenge, was read that ROM and put it here. And it is there. So if you see, third one, FE, FF, and so on. Of course, here in the code we are doing println, so it's not so useful. But now at least we have a byte. So now, oh guys, I probably need to end this stream early today. I have an appointment, but I really like this, so I will git status. So yeah, let me see what this git ignore is about. Yeah, okay. I'm not sure if I can put this, so I will, yeah, I will put this wrong start into the git ignore. So yeah, no wrong. So git add, git commit, first commit. I'm using to do this first commit. So git commit, reading from the boot ROM, and debugging as U16. Yeah. Oh, sorry. I think I did not config my email. Yeah. So my name. Nice to meet you. My name is Douglas Silvio Correa. And let's do that commit again. Okay. Well, I committed this idea. I like that. No problem. Git status. So git. Oh yeah, I need to create a. Let's create a repository there. New repository. Well, what's the name? GB Rust emu. GB. So gbrust. Gbrust emu. Nice. Okay. Okay, I'm not be doing. Okay, I will not add. Wow. Let me create this readme. Okay, let's do this. Whip Gameboy Emulator. I'm creating this GB emulator in Rust while learning Rust programming language and emulation stuff. How this, and I'm also streaming this on Twitch and putting and records. Okay, VODs are also available. YouTube. So my propaganda. Okay, so I have those thousands of accounts, which everybody does. Yeah, no new. Oh, what's that? No, I don't want to this. Well, this guy is amazing. So yeah, let's go to my channel. Let's grab my URL. So if I'm not wrong, I can put a link. Oh, sorry. Nope. Like YouTube channel. Yeah. And the same for Twitch channel. Which is how the Twitch channel is easier. Twitch TV dot Douglas Korea. Okay. So git status. Okay, let's go to this. Git status. Git add. Commit. The readme. And then get back to the here. It's easier to just copy and paste. Okay. Paste. Ta-da! Oh, it is there. Okay, it's there. Okay, so Rust Emulator Gameboy Emulator. Okay, Twitch. Blah. Okay. And web game by emulator. Okay, so more propaganda. Great. So guys, well, as I said, I need to learn a lot of things about this Game Boy stuff. I already learned a lot about memory. I read those documents yesterday. I continue reading these, but I took this decision to start coding. And by starting coding, I started reading the Boot ROM, which is a very small ROM that is inside the Game Boy, which makes that shiny logo. So of course I need to create all those CPU, PPU, memory structure, and in memory doing the LCD manipulations and so on to be able to show something in this screen. But at least we have a starting point. So right now, if you come here, cargo RAM, we are just so let me do something. Hmm. Yeah. Actually, yeah, I need to create some structure. Let's do this. And this will be RAM. ROM. Let's put this way. It's a vac of U8, right? So this is a vac. Actually, it's an array. How long is this? Well, from this point, let's put this bank rows. No, let's put 32. So it's 32. Yeah. So 32 segment 8. What's that? Why that's wrong? Oh yeah, it's not a comma. It's here. So it will be an array of u bytes, and it will contain 32 kilobytes. So yeah, I can also have now a pub structure called CPU, which here we will have all the registers, but I'm interested in one special register, which is the program counter, because it will point to the ROM. So we can, the idea here is copy what is inside the ROM file to the memory and read it as an 60-bit word, because then we will have something like this, like 31FE, which will end. Oh, I have a dog, man. Yeah. So third one FE, third one, third one. Yeah. So it's an load SP instruction, which I don't. So let's do this load SP. Yeah. So it's put value n into n. So put h. Oh yeah, this is about that special register. In this, we just talk about the video, but we didn't talk about today. We didn't talk about the registers, which are here. Yeah. So this special HL register holds an 16-bit address for being used when we use those kind of load move, which will point to another direction. So 31 FE, so it would be like 31 FEFF. Oh, but this is in reverse way. Yeah, 31 FF. Why it's in reverse way? Because of that big Indian stuff. Where is that code? Where is that code? Here. Haha. Load SP FFFA, and it is FFFFE. Yeah. So the third one is this and the FFFE. So we just put this in. So this is the exactly what it's doing. So why getting back to the code? I need to. Right now we are reading this like directly as a byte, and well, besides this, it will show this. We need to read this on in a way that we can get this. Well, we need to read this as the program counter tell us to read. So in a 16-bit address. So tomorrow I will be copying the values from the ROM file to the memory in the ROM area, and this which I barely did here, and then going incrementing the program counter and going one by one, trying to decode this and end up with this nice decoded boot ROM, where it is somewhere here. So after reading this, I need to be able to do this. Okay, so of course not only disassembling, we need to execute the structure itself. Just comments for the bootstrap system property system. Nice. Okay, so I think we can call this a day. Oh, I decided to go in a way that I think we will be able to see stuff earlier than only coding, 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 and it would be nice to me and also for you, for somebody that is watching. Uh, and I think it would be good. Yeah, and I think today it would be a shorter stream. So, guys, see you tomorrow, guys and girls, and wherever is watching. See you tomorrow, the same time. Like I said, about 6:30 p.m. EST to 8:30 p.m. EST. Today I need to leave early again because I have appointment. And tomorrow I will be here again. See you guys. Thank you for watching.